Is your own body a mystery to you? Do you wish that you could have a better understanding of how your body functions or what's happening inside of you? But do you find that those terms of anatomy and physiology are daunting and overwhelming? Welcome to Wonderfully Made, where the mystery of your body is revealed. Have you given much thought to breathing? Now that I just asked you that question, you are aware of how you're breathing. How long would you be able to hold your breath for? Good evening and welcome to Wonderfully Made, where the mystery of your body is revealed with me, Khomotso Mokhapi, right here on Life Destiny TV, your life, your destiny. Today we're talking about breathing. Well, we're talking about the respiratory system. In answer to one of the questions, you cannot live without oxygen for more than 3 minutes. That's a very short time. And it shows us just how important breathing is, but we don't think about it. Why? Because it's not our responsibility to think about it. Our body is created in such a magnificent way that breathing happens on its own, whether we're aware of it or not. Just imagine if you had to keep thinking about how you're breathing, whether you're breathing right, how many times you have to breathe in a moment. You could just forget, the same way you forget where you put your car keys, but if you forget for more than 3 minutes, you would cease to exist. This shows how wonderfully we're made, that our brain takes care of the things that are critical for our survival. So today we'll be looking at the respiratory system. This talks about anywhere from the nose all the way to the lungs. What is the function of the respiratory system? It really is to get oxygen in and to let oxygen out. There are two parts to the respiratory system. There is what we call the conducting zone and a respiratory zone. Let's have a look at the conducting zone. The conducting zone is simply that part of the respiratory system that conducts the air from the outside into the lungs. Let's say that again. The conducting zone. It starts at the nose where oxygen or air is allowed into the nose, and then it travels down a pathway all the way to the back of your throat, down your trachea, all the way into the lungs where there are tubes until the air gets into the alveoli at the end, just before it's transported into the blood. That is what the conducting zone is. The passageways that lead the air that we breathe in from the outside all the way to where it is needed, which is the respiratory zone. So why is the conducting zone important? Well, it's not just the passageway to allow air to move. If you can imagine that in the air, there isn't just air, and the air is composed of nitrogen, of oxygen, but you also have particles, so dust particles, flower particles, we call them pollen. You have germs in the air. Now, some of these things, you do not want them getting into your system. When I talk about your system, I mean you don't want them getting into the blood. Remember that the whole point is to get oxygen into your lungs and from your lungs into the blood, from the blood all the way to the different cells. Now, you don't want the germs. You don't want the dust. You don't want the pollen. You don't want any of these other things ending up in your blood. So the function of the conducting zone is to now start a process of cleaning the air. So in your nose, as you've seen, you've got little hairs. And what do? They trap the big particles. So that's why you end up with a little bit of snot. We think it's disgusting, but it's the body's way of ensuring that nothing that is too big that should be going into the rest of your system is moving past it. But that's not the only thing that happens in the conducting zone. It is an amazing thing. So when people say they have sinuses, they think they have a disease, right? Well, let's learn what sinuses are because they form part of the conducting zone. What sinuses are in the nose, they are bones, and within these bones, they're not solid bones. They're bones that have spaces or pockets where air can filter through, and they are covered with a membrane, so almost like a carpet. So what is the point of this? Well, if the bones were solid, your face would feel heavy. So the bones have little pockets of air. And then what happens is it increases the surface area. So as you breathe in, the air goes into these spaces. And what happens when the air passes there? Well, this layer, this carpet that's there, has cells that have what we call goblet cells, which produce mucus. Yes, so when you have a runny nose, your own nose has made that mucus. What does the mucus do? It also continues to trap the particles. So if you're in a dusty area, you'll see that you have more and more mucus coming out in a form of a runny nose. What else happens in the sinuses is that the air that you breathe in is humidified. What does that mean? It means it's made, moisture is added to it. Because the air that we sometimes breathe in, depending on where you live, can be so dry and it's not good for your body, so it's humidified. So these are the two important things that happen in the sinuses, in this conducting zone. There is mucus, and the mucus can trap the dust particles, and the mucus can also humidify the air that we breathe in and also make it warm. Remember that the body temperature is 37. So if you're out and it's a cold day and the temperature outside is 5 degrees, you cannot have air of 5 degrees going into your blood. It's going to create a problem. Therefore, your conducting zone is responsible for making the temperature balance with the temperature of your body. So let's recap what we're talking about. We're looking at the respiratory system, and it has two zones, the conducting zone and the respiratory zone. Right now, we're focusing on the conducting zone, the passageway that leads the air into the lungs. But we're still in your nose. You never imagine that so much work can be happening in such little space. So what did we say happened in your nose? You have the sinuses, which are bones which have pockets in it to allow the air to move, and these air spaces are covered with a mucous membrane or with a blanket that have cells that can produce mucus, and the mucus traps the dust particles and the germs and the pollen, as well as humidifying the air, also making it warm. So what happens once it has done all of this? There are little hairs, not the ones that you can see, other little hairs called cilia, and what they're responsible for doing is usually they then cause the mucus to flow back. So have you ever felt that you were swallowing some mucus from your nose? You know when you get that post-nasal drip, you just feel the dripping to the back of your throat? That's actually what is supposed to happen. Your body is engineered in such a way that once the big particles are trapped, they are sifted back. The little hairs sweep them back to the back of your throat so that you swallow them instead of breathing them in. So then what happens on a cold day that you end up having a runny nose, or when you see somebody having a runny nose? Well, the little hairs work best when it's warm. Cold weather causes them to be slow in how they move. So in as much as some of the mucus is going to the back of your throat, because they're not moving as fast as they can, some mucus will come running down. So that's why when you're in a cold environment, you tend to have a runny nose. And all you need to do, you're not sick. You just help your body and you blow out, and that is how you get the mucus out of your system. Isn't the body amazing? So now you have a better understanding of all of us, we have sinuses. There can be a problem when if your sinuses overproduce the mucus, or if the carpet that is covering it becomes swollen and inflamed, and that's why you feel as if the air is not moving, because if it gets swollen, it blocks the different spaces. And also now you understand that the air that you breathe needs to have as little dust as possible, otherwise you're creating work for your body. Little germs as possible, otherwise you're creating more work for your body. The air needs to be as moist as possible, otherwise you're creating more work for your body. And the air that you breathe needs to be as warm as possible, otherwise you're creating more work for your body. So if you tend to have problems with your sinuses, you want to ensure that where you live, especially in your bedroom, you don't have anything that causes dust to accumulate. You don't have little plants that are throwing around pollen all the time. You don't have, it's not too cold and it's not too dry, so you may want to get a humidifier. So we got the concept of a humidifier from studying the sinuses and ensuring that the air that you breathe is nice and moist and warm. You never thought that so much work is happening in your nose. So you will have a little bit more respect for your nose. It's not just that thing that creates snot and mucus. It does amazing work preparing the air that you need for the rest of your body. We'll be taking a break. Join us after this as we continue here on Live Destiny TV. Welcome back to Wonderfully Made, where the mystery of your body is revealed with me, Khomotso, right here on Live Destiny TV, your life, your destiny. Today we're talking about the respiratory system. If you've just joined us, you missed talking about the nose, which is part of the conducting system. So we've been talking about the nose, and the nose is part of the conducting system. What also happens in the nose, just a small bit about it, is the sense of smell is in the nose. Why is the sense of smell important? It alerts you as to smells that are dangerous to the body, as well as smell is linked also to taste. Some of the smells, things that are dangerous to the body, imagine you're in an environment and somebody is smoking and you're a non-smoker. You can quickly pick it up. Why is this important? Because your body recognizes that what you're smelling does far more harm than creating an unpleasant smell where you are. There are chemicals within cigarette smoke, but not just cigarette smoke, other fumes from paint and nail polish and all these other things that affect your body in a negative way, in different kinds of ways, especially if we focus on cigarette smoke. If it ends up in your lungs, it could cause damage to your lungs, but they can also cause the little hairs that we're talking about to not move as well as they're supposed to, meaning that they will not be able to move the mucus out from where it's supposed to be. So a sense of smell is important. Have you ever been in a car and somebody's wearing too much perfume? Your body is telling you that those particles have gone into your body and they're going to affect you in one way or another. Either they will affect a part of your brain, they will definitely affect a part of you. And these are the different smells, perfumes and paint. You know that paint will end up giving you a headache because it's causing damage within your brain. So that's why the sense of smell is important, and this is found in the nose where the conduction of air is also happening. Remember that when you smell the fumes, they are not just nothing, they are particles. Even though you cannot see them with a naked eye, they still have an effect on your body. So this is important. So the room that you're in, it's important to ensure, in as much as you need to ensure that the air is warm, that the air is humid or moist, that the air is also free of dust particles, of germs, but also of other particles that you can smell. You need to make sure that you aerate the room, so where you open up so that fresh air can come in. So the conducting system doesn't just end in the nose. So we said when the little hairs with the mucus push it back or sweep it back, it goes to the back of the throat. So there's another part that is part of the conducting system. You have the pharynx, and the pharynx is divided, which is the throat, it's divided into three parts. You have the nasopharynx, which is just behind the nose. And the interesting part about the nasopharynx is that your ears also link to your nasopharynx. So you know when you're on a flight and you feel a pressure in your ear, how do you release that pressure? When you open up your mouth. That's how the ears are linked with the mouth or the back of the throat, also linked with your nose. And then below you have the oropharynx, meaning it's at the level of the mouth. And below you have the laryngopharynx, which is when we go into the larynx, or the trachea, which is where the voice box are. These are all part of the conducting system. They are just leading the air from the outside through the nose, through all these different parts of the pharynx, all the way into the lungs. Now, what I need you to remember is that it is important that you breathe in through the nose, because as you can see, the nose was created for breathing, not the mouth. You don't have the little hairs in the mouth. You don't have the mucus. So if you're breathing in through the mouth, you're allowing big particles to bypass the conducting pathway. So there'll be nowhere to warm up the air, to humidify it, to clean it before it arrives at the lungs. So ensure that you take a deep breath through the nose, and you can breathe out through your nose or through the mouth. That's the important thing we want to share. Now, when we continue and when we look at the beyond the voice box, most of us think that this is part of the respiratory system. Well, yes, but not part of the respiratory zone. It's still part of the conducting system, because what you find is more and more tubes going down. If I can give you an example, when you hold a bunch of grapes and you see that big stalk, and then it breaks into little stalks, and then more little stalks until you get the grape at the end of it. That's what the lungs look like. So the big stalk would be your main conducting pathway, and then it will divide into two, and then it will subdivide into smaller conducting pathways until you get an alveoli, which literally looks like a grape, which is where the respiratory zone is. What the respiratory zone is where oxygen and blood are close to one another, so that the oxygen, the gas, oxygen can flow, move into the blood, and carbon dioxide can move into the alveoli, so that the oxygen can be taken to the rest of the body and the carbon dioxide can be moved out. Now, when we look into the chest, we see the two lungs. Now, the two lungs are not the same and they don't have the same size. The right lung has 3 lobes and the left lung has 2 lobes. And the reason the left lung has 2 lobes is because majority of the space that would have been for the 3rd lobe is taken by the heart. But they serve the same purpose in receiving this air that has been humidified, that has been warmed up, and they allow it to move to the respiratory zone. So let's now look at the respiratory zone. But before we continue to the respiratory zone, just take a deep breath through the nose, yes, and relax, and I'll see you after the break. Welcome back to Wonderfully Made, where the mystery of your respiratory system is revealed with me, Mohapi, right here on Life Destiny TV, your life, your destiny. So already what we've covered is what happens in the nose. We've talked about the sinuses and how they're important, how all of us have them, and that people who say they have sinuses, what they mean is that they have problems with their sinuses. And we've discussed how you can go about preventing those problems and how you can help your body. Because the whole point of understanding the anatomy and the physiology of your own body through this show is so that you know what to do, how to work with your body. So as you take a deep breath, which we did before the break, the air went through your nose, the big particles, whether it be the dust or even the perfumes or everything else that is not good for your body, were kept by the mucus, and the little hairs in your sinuses and in your nose swept them back to the back of your throat. And as a grown-up, you can either choose to spit it out or you can swallow. It will not create any harm to your body because your stomach is acidic. And then what's purified and what has been humidified, so what's purified, what has been cleansed, what has been humidified, what is moist, and also what is warmed up, that air will continue to your pharynx and then through your trachea, all the way into your lungs, through the different bronchioles until it arrives at the alveoli, which are the little sac things in your lungs, where is the respiratory zone. So we're done with the conducting system. So what happens at a respiratory zone? The respiratory zone is an area where exchange of gases happens. So what are the gases that need to be exchanged? You need to take the oxygen from the air that you've breathed in to go into your blood and to take out the carbon dioxide that is in your blood to go into your lungs so that you can breathe out the carbon dioxide. Do we get that? So this is what happens in the respiratory zone. So this air arrives with about 21% of oxygen if you're living in the purest place we can find, or it could be less if you're living in a polluted place, or if you're in a room where the windows are shut, you know that the oxygen level will not be 21. And what happens is that through different processes, the oxygen moves into the blood. When it arrives into the blood, we've spoken about this when we spoke about blood, remember that show? That the oxygen will then go into the red blood cell, which works almost like a taxi or a shuttle, that will then move the different oxygen molecules. So it'll take the oxygen, it'll take it to the heart, it'll take it to the brain, it'll take it to the different muscles, to the livers, because every single cell needs oxygen. When it arrives at a cell, gaseous exchange also happens, changing of gas. So when it arrives at a cell, it will offload the oxygen, and then it will unload carbon dioxide, and the carbon dioxide will then be brought to the lungs and taken out. But here's the thing, while oxygen is transported in the red blood cells, carbon dioxide not necessarily. So carbon dioxide will go into a red blood cell, and then if there's too much of it, it will move out into the blood and travel as bicarbonate. Remember when we discussed the pH of the blood, we spoke about bicarbonate? It's made from the carbon dioxide that goes into a red blood cell and then moves out then into the blood. So how carbon dioxide is transported is that 10% of it is transported just as carbon dioxide in the blood, 70% of it is transported as bicarbonate, and 20% of it is transported in the red blood cell. And then it moves to the lungs. When it arrives at the lungs, the carbon dioxide, the one that's in the red blood cell, will move into the lung. The bicarbonate will go back into the red blood cell, become carbon dioxide again, and then move into the lung. And the other one will just diffuse into the lung. And then you breathe it out. And as you breathe it out, you can breathe out through the nose or you can breathe out through your mouth. It really is not important because the stuff is coming out. So it doesn't need to be cleansed. It doesn't need to have anything done to it. That is simply what happens at a respiratory zone. So what are the problems that could happen at a respiratory zone? Well, there could be a problem with the alveolar sacs themselves, those little grape-like sacs. So what could cause a problem? Lung diseases, chronic lung diseases, such as in people who smoke. They could change the structure so that the movement of oxygen across that exchange layer is not as good as it's supposed to be. We've seen that in smokers, this is where the damage happens. And that's why then they lose the functionality of their lungs. It means you have less space where gases can be exchanging. And if there isn't enough space for gases to be exchanging, it means you're not getting enough oxygen. The other thing that could be a problem is in the blood itself. If you don't have enough red blood cells, because you need them for the transport of oxygen, then you won't be able to get enough oxygen moving through. But remember that it's highly unlikely that you would have a problem with the carbon dioxide because it moves through the blood in different ways. Now, what controls our breathing if we're not doing it ourselves? The breathing is controlled by the autonomic nervous system. So there's a part of the brain that controls how deep we breathe in, and also how fast we breathe. We breathe about 18 to 20 times in a minute. However, you can change. You can decide you want to breathe more. But here's the beautiful thing. If you decided that you want to breathe 30 times in a minute, if your body does not think that is a good idea, you will hyperventilate, you will start to feel a bit dizzy, and then you will fall down and faint, and then your body will take over. If you decide that you don't want to breathe for the next 3 minutes, try it, and you hold your breath. There will come a point where your body takes over. Why? Because your body needs to maintain homeostasis. It needs to continue you living. So it will override your decisions if it thinks your decisions are not in the best interest. Isn't the body amazing? So now we've discussed the respiratory system. We've looked at the conducting zone and we've looked at the respiratory zone. Now we'll be taking a break, but be sure to join us after this break, for we will be talking about, yes, you guessed it right, New Start. What are the things that you can do to improve the functioning of your respiratory system? See you after the break. Welcome back to Wonderfully Made, where the mystery of your body is revealed with me, Khomotsomokgapi, right here on Life Destiny TV, your life, your destiny. We've been learning about the respiratory system today. We learned about the conducting zone and we learned about the respiratory zone. Now you have a better understanding of how this system works. Now we need to look at what is it that you can do to make sure that it works at its best. Remember that it is controlled by your brain. So do not try and take over. Do not hold your breath unnecessarily and do not breathe fast for no particular reason. However, what you can do is improve the depth of your breathing. So every now and again, within a day, you can take deep breaths to ensure that all your lung is being used. To improve your lung capacity. But the best way to do this is with, you've guessed it, exercise. So when we're looking at the 8 laws of health, we will look at the law of exercise, because exercise helps you to improve the lung capacity. Because what happens during exercise, there's more of a demand for oxygen. More oxygen is required, and it's required faster. So you start to breathe faster so that it can, because the blood is moving faster. So you breathe in and out faster, and you take deep breaths so as to allow more oxygen to be coming in. So you're recruiting even those parts of the lungs that were reserved for something else, for another day, allowing them to work and participate in the respiratory system. So exercise is important for improving your lung capacity. What about the law of nutrition? How can that affect your respiratory system? Well, there are certain foods that causes your mucous membranes to release more mucus. And remember what we said in the conducting zone. If you have more mucus, it needs to come out. But sometimes it can be so much that it blocks the passageways, the conducting ways. So what are these food products that increases mucus secretion? Dairy products, milk products, cheese. These are the things that causes your body to create more and more mucus. So it's important to watch what you eat, as well as some spices that you eat. So if you've got sinus problems and where you feel that your sinuses become easily blocked, monitor what you eat. Abstain from these, from the spices, and abstain from the dairy products, and see how your sinuses clear up. So that's in terms of nutrition. But are there foods that you can eat to clear up your conducting pathways? Absolutely. You can eat ginger. You can have onion raw, yes, especially red onion. It's a bit of a milder flavor. You can make your own cough syrup. Now, this is important, actually. I would like to focus on this. Often when we have a cough, what we tend to do is run to the pharmacy and want to buy a cough suppressant. Now let's understand, why are we coughing? When we cough, our body is saying there is something in the body that is not supposed to be there. So your body, it's irritating the body, so then it causes the body to do what? To cough. To cough is simply that the air that's coming out of the body is coming out with such a force, trying to remove that thing that is irritating the body. Now, if you take a cough suppressant, you're saying to the body, don't take this thing out, allow it to stay, which can then create problems for your body. So we should not be taking cough suppressants. That is working against your body. So what can you do? You can take in something to stimulate the cough and to create more of the mucus to help you expectorate. So these are what we call expectorants. You can make your own at home using onion and honey. So you just layer different, you just take layers of onion, and then you put honey and onion and honey, and you leave it in a glass jar for 24 hours, and the liquid that comes from it, you can drink that. And that can serve as your cough suppressant, because the onion will then help to make your mucus secretions a bit lighter so that you can cough. Now also, the law of water is important. How is it important? Well, mucus is made from water. So if you're dehydrated, you may be making secretions that are thicker. So you want to make sure that the secretions are a bit lighter. And then obviously there is the law of air. What's important about the law of air? You need to make sure that the quality of the air you're breathing is good. It needs to be as fresh air as possible, that you can find in gardens, in the botanical gardens, where there's just lots of trees, because you've got concentrated oxygen. Obviously, if you are more prone and allergic to pollen, that might be a problem for you. So, and if you're allergic to grass as well. But you want to be in places where it's open spaces, not in rooms that are closed. So that's why it's important when you're sleeping at night, you're still breathing. So if you're sleeping at night with all the windows and all the doors closed and your home does not have air bricks, it means you're breathing in your own air over and over again. You're not getting new fresh air. The same thing for people that work in environments where all the windows are shut. So your office space is underground and there isn't really any fresh air coming in. So the air might be cool because the air conditioner is on, but there's no real fresh air coming in, and that creates a problem. So your brain starts to become a little bit slow because it's not getting good quality oxygen. And you also don't want to be around people who smoke. You also need to avoid heavy perfumes, because those particles, your body has the burden now of trying to get rid of them. And over and above that, those are chemicals that will affect parts of your body in different ways. So it's important that we not be using so many air fresheners. If you were to look at the ingredients list on those, you find it's chemical after chemical after chemical that now your conducting system must deal with. If they end up in your blood, then your liver has to deal with. So we want to create less work. So in short, eat what is right, exercise to increase your lung capacity, drink the water to make sure you're able to make mucus as you need, sleep in a room or work in an environment where the windows are open. If not, take an air break, not a smoker's break. And this is how you improve the functioning of your respiratory system. I hope that you've learned a lot from today's topic. Please be sure to tune in next week when we continue to teach you about fascinating parts of your body. So from me, Khomotso Mogapi, from Wonderfully Made, right here on Life Destiny TV, your life, your destiny, I say good night.